Окей. Не знаю, по-русски, мне по-английски, ну, наверное, по-английски раз. Значит, идея такая, что ну, те, кто на семинар просто пришел, то как бы, извините, мою лекцию, половину семинара, только, по крайней мере, будет лекция. Вот. Ну и хорошо, что пришли. Вот, значит, что мы делаем, собственно? Ну, по-быстрому, я не знаю, чтобы как бы люди не скучали. Мы доказываем такую теорему. Очень важную. Вот такую. Значит, которая говорит, что локально геодезическое минимизирует расстояние, минимизирует длину кривой. А длина кривой считается вот так. G это, значит, ну, Риманова метрика G, то есть она на каждом касательном пространстве, в каждой точке дает, соответственно, невырожденную симметричную линейную форму, но более того, не только невырожденную, но и положительно определенную. Вот. Но вот это длина кривой, так считается. Вот. Я говорю, что ну окей, у меня есть Риманово многообразие, на Римановом многообразии есть кривые, я умею считать, но я умею как бы находить их длины. Вот. А с другой стороны есть связность выделенная, которая называется связностью Левичевит. Это, ну я не знаю, она где-то тут определена. Да, вот есть связанность Левичевита. Во-первых, она без скручения, вот, а во-вторых, она инвариантна относительно, ну, G инвариантна относительно ковариантной производной. Вот. Ну и вот утверждение, что если я посмотрю, значит, на N0, это такой, значит, шарик в TPX, с которого экспоненциальное отображение бьет дифеоморфно, вот, то тогда, ну и там, значит, для каждой точки Q в таком шарике есть единственное геодезическое, которое соединяет P и Q, вот, а шарик центрирован в P. Вот. И говорится, что если я посмотрю на длину этой геодезической, то она всегда будет меньше, чем длина любой другой кривой. Причем кривая, в принципе, может вылезти за шарик, но гаммы по Q нет. Вот. И идея доказательства такая, что мы возьмем, посмотрим в сферических координатах на этот шарик. А сферические координаты такое, что вот я просто смотрю на этот, значит, шарик без нуля, на нем ввожу вот сферические координаты. S это сфера с радиусом 1. Вот. Ну и просто отображение вот такое. Его компоную с экспонентой. Вот такой φ там задает мне координаты вот на np без π. Я хочу посчитать, как у меня Риманов, моя метрика выглядит в таких координатах. Вот. Идея как бы доказать, что там нету перекрестных слагаемых. То есть у меня есть только слагаемый типа квадрата того, что живет вот здесь, типа квадрата того, что живет здесь, а нету слагаемых типа dt там на dφ, где dφ это координаты здесь. Вот. Ну а почему это нам поможет? Потому что как бы геодезическое будет давать только вот этот вклад, а все остальное будет давать вот этот вклад и еще вот этот. Ну и поэтому любая другая кривая будет длиннее. Вот. Значит, идея такая. И мы уже посчитали, значит, ну мы тут разного вводили в двойственный базис в TPX относительно G, омега-иты, ой, в смысле ортонормальный базис. Омега-иты это, соответственно, двойственный базис ксиан в точке P, и он как бы распределен во все другие точки с помощью параллельного переноса. Вот. И мы как бы посчитали, что такое, ну уже тогда будет просто сумма квадратов омегаитых. Вот. И мы посчитали, что такое, значит, омегаиты вот в сферических координатах. Но не до конца. Мы, значит, сказали, что пусть у нас как-то так расписывается, посчитали, кто такие f-иты. F-иты, они вот такие функции, которые смотрят на точку, это как бы это радиальный, значит, координата, а это то, что на сфере живет. И вот она раскладывает их по осям и, значит, выдает мне коэффициент аиды. Это аида такая будет. Вот. Собственно, остановились мы на том, что прекрасных слагаемых нет. Вот мы хотим это сейчас доказать. Окей. So for non-Russian speakers, I just reviewed what happened in lecture. Maybe we had some interest in what's going on.
Это сейчас записывается?
Okay, so we'd like to prove this. Yes, and so also during the break I said that I'm following, or rather inspired by the book by Sigurdur Helgason, which title starts with differential geometry, but also it's like some other words like groups, I think symmetric spaces or something like that. Yeah. Right, so I'm proving claim 2 then. How to do this? Well, I need to introduce to prove. Let me define VIs. So these are psi i's, again, extended to the whole NP by parallel translation. So VI, these are in vector fields on NP. Right? NP is our normal neighborhood around P by the following. So Vi at point Q is just tau 1 of psi I, where tau t is parallel translation with respect to gamma pq. Okay. Then actually it's true that for any point q, vi at related omega I related to vj is just delta ij. Then this happens. All right. Okay, so now I'm applying one of the homework problem, because I can now compute what is d omega I in terms of connection. Remember, I could write something like this: d omega I is a sum over j from 1 to n. And then I have to write omega j, which nabla, which is nabla star, but we don't write star anymore, vj omega I. So this is from homework problem, and we're using that nabla has no torsion. So by homework problem, using that nabla has no torsion, because it's Levi-Civita connection. Okay, now I actually can write what is this guy, just using Christoffel symbols. Nabla Vj omega I is sum over k gamma. And then now I really need to be careful about indices. So I just need to go back to the definition of Christoffel symbol, but I think it should be like that. So these are Christoffel symbols. well, corresponding to the star, to Nabla star. Nabla star here. Right? Nabla star here. So this is just a definition of Christoffel symbols, really. Okay, then I take this and substitute to here. All right. Then I have what? Then I have the following thing. Right, d omega I is also if you right, so let me just substitute. I will have sum of j and k gamma star ki j, right, omega j wedge omega k. So this thing. But I don't know, I hope on the seminar we would express gamma star through gamma, but I'll just give you the answer. It's really, so it's really, so gamma star is Christoffel symbol corresponding to Nabla, which is Nabla star, which is equivalent to Nabla, and then it's expressed through original Christoffel symbols as follows. It's gamma with minus ikj. And so this is minus sum over j and k gamma I k j omega k. Okay, so our goal is actually to compute the derivative of this guy with respect to t and see that it is 0. Then we can, see that its limit at t goes to 0 is actually 0. Right, because omega bar is 0 over there. So this will give us this result. So, okay. But how do I compute this derivative? I really compare two things. I really compare phi star of d omega. So I compute this guy in two different ways. So first is, well, because d commutes with the pullback, so first I have this. Phi star of omega I, well, is just by definition d fi fi dt plus omega I bar. And so I'm claiming that this, so I need to collect terms in front of dt. So this will be dfi wedge dt plus dt wedge d omega I bar over dt. So that's the term that is of importance for me because I'm actually computing the derivative of this with respect to t. Okay, so now n plus something else which I don't care about because it will not have dt inside. Okay, so I'm finding all the terms with dt. Well, on the other hand, I can compute it in different way using this. So when I use this, well, this basically will give me minus sine over kj and then gamma kj I, and then I need to take phi star of j, phi star of omega j, and then wedge phi star of omega k. Well, of course, it's also I need to pre-compose this with phi, right? It's like also phi star of gamma, but you know, right? I'm kind of just computing gamma now in spherical coordinates. That's what it means, right? These guys also phi star of omega is this, so therefore I can write it like that. So it's just minus sum over gamma. Well, maybe I need to start with a fresh slide. So this is the following thing: minus sum over k and j, gamma I kj, and then I have fj dt plus omega j bar, wedge f k dt plus omega k bar. All right. So now I am collecting terms with dt, really. Right? So this will be what? If I collect terms with dt, it will be minus sum over k and j, gamma kg I, fj omega k bar with minus sign here, plus fk omega j bar, wedge dt. Plus something else I don't care about, so I really need this term. Okay, so now I'm comparing this with that. Okay, and I see what? That d omega I bar over dt is well, dfi, first of all, right, from here. Well, if I switch it, it's with minus, and then I send it to the other side, it will be plus dfi. Plus, actually, sum gamma I kj fj omega k minus with bar fk omega j bar. And here sum over k and j. Okay. And so finally, so we have this, therefore, if I take sum over fi omega I bar, compute its derivative with respect to t, then I will get what? So d over dt hitting this guy, this will give me sum over fi dfi. All right. Yeah, and by the way, fi is constant with respect to t. If you recall, right, fi just of t sum over aj xij just gives me aj, does not depend on t at all, right? So d over dt does not touch this guy, so I have so it's just sum over fi of this expression times this expression. So plus, and what I have, sum over I, k, and j of gamma ikj minus gamma ijk of fi fj omega k bar. So my goal now is to see that this is 0. So we want to see that this guy is 0. Because then we're almost done. This is differential of fi squared, of sum of fi squared. And sum of fi squared is 1 because it's it gives me coordinate of a vector on a sphere. So sum of the coordinates of a vector on a sphere is 1. So differential of such thing is 0. So then this will be 0. This is actually 0. So this is d sum of fi squared, which is just d of 1, which is 0. So this guy is 0. So the most non-trivial part is to see that this is 0.
Потому что навык без кручения.
Вот это 0?
Да. Нет?
А вот?
Не следует.
Ну, хотелось бы, да, чтобы и анасимметрично относительно EG было.
Сейчас нет, у нас же была вроде задача, что если...
Была, но задача неправильная.
Вот.
Задача, да, правильная, только для гамм, написанных для коммутирующих векторных полей. Ну, наверное, мы пытались сказать, что для любых, и вообще задача была для любых, но это, вообще говоря, неправда, это ошибка.
Понятно.
Вот. То есть вот то соотношение, что оно там симметрично относительно, относительно как раз G и K, вот, это правда было бы только если бы вот эти поля в и и в G коммутировали. А так, что значит, на самом деле у нас вот это выражение, это просто по компонентная запись вот такого. Вот. И когда у нас нету, то есть когда у нас нету кручения, это то же самое, что в ит с выжитым. То есть реально это структурные константы вот такой вот алгебра Ли, натянутые на в и выжитые. И если они не коммутируют, то никто не обещал, что это 0. All right. So this. So and actually, both of these guys, they just not like one cancels to other. So they both go to 0, both these terms, for separate reasons, actually. Let's see. So I think this one, so if I consider sum over this, this goes to 0 because of invariance of G. So I have nabla vi vj, as I said, this is just gamma k j I v k, sum of k. All right. So this is just definition of Christoffel symbols. So therefore, if I take Riemannian structure computed at Vj, Vk, and differentiated with a vector field Vi, well, first of all, this is delta Jk, right? So this is just Vi differentiating of a constant function, right? So this is just 0. Because this is actually a constant function, this is just delta Jt, burning point. On the other hand, because of the invariance of the form, we actually computed it some number of slides ago. maybe not here. Where was it?
На левой части.
Да, на левой части. Да, вот. Вот. Значит, yes. So I'm using this guy. Wait, some reason I don't have. So let's see. So what I'm claiming that this is just G nabla Vi Vj Vk plus G Vj nabla Vi Vk. Right? But also I had what? Also, I think I had commutator, right? So what else I should write? So I think I'm missing commutator in my notes. That's why I'm a little bit stuck. So I have also G of V and W Z. Right? So let's try to see why this is not in my notes. Maybe it's just 0. So it's plus G. What should be a Vj and V. Right, and Vk with Vi, Vk with Vi. Yeah, I don't see why this is shouldn't be 0. Because this is like again some because then this is okay. So what I'm saying is then this is just gamma. So this guy is gamma kji, and this guy is gamma jki. So I really don't want this term. So for some reason I'm having it, which is I don't know. I don't see why I don't know. Is it 0? That doesn't seem like. So okay, I don't want to stuck on it right now, but maybe let me try to go forward. So it's just not in my notes. I don't know. Maybe I just missed it. But if this guy is 0, then this is just 0, right? And then this term is gone because this is just antisymmetric with respect to I and j, right? So this guy is symmetric with respect to I and j. This is antisymmetric with respect to I and j. Okay, but I don't know. Maybe
Why the second, the third element appears in some? Why the third element appeared in the sum?
Yeah, this one?
Yes.
Yeah, so I'm looking at this formula. This one. So this is this element. So I have this. I have this. So then if I substitute v vi, w vj, and z vk, then what I have is this guy. Okay, I'm not sure now. So maybe.
Can you write
Yeah, sure.
the formula? I will have the formula where we don't have this y appears. This one.
You mean?
Yes.
Yes. Sorry. So we have this, right?
This.
Why do I have this guy?
We don't have it in this.
We don't. Yeah.
Yeah.
Why do I even write this? Yeah, you're right. Let's see. How did it appear here? I have no idea. It's magic. Yes. Yes. Thank you very much. I don't know why it's here.
Подождите.
Maybe I explained something.
Да, не, ну там нужно просто расписать через, потому что учения как бы не было, мы расписывали применение набла z.
Да, точно. Мы переменяли, а я использую вот эту формулу.
Да.
Вот.
Успех.
Успех, да. Ну вот тут, видите, тут такая многоходовочка, поэтому запутаться сложно. Легко. Значит, я использую вот это, правильно? И мне нужно один и тот же аргумент здесь. И поэтому здесь у меня ZGVW, и здесь я как бы не меняю, поэтому вот этого у меня нету. Да? Окей? А вот это я как бы два действия сразу сделал, а мне нужно только одно. То есть нету той формулы, которой я хочу воспользоваться. Мне нужно без этого и здесь поменять ZW. Вот. Теперь все сходится. Значит, вот это мне не нужно вообще, тут нету этого. Потому что и здесь VI, и здесь VI.
Вопрос.
Да.
Вот у нас же все-таки в этой задаче связаны две вещевиты, да, используются?
Да.
Кристофили к ней относятся, да?
Да.
Ну, там же точно можно нижние индексы представлять.
Не точно.
Точно? Ну, просто я еще раз прогуглил, там написано, что можно.
Но это неправда. Вот, значит, потому что вот это. Если...
Да, выразить кристофили через метрику, получается, что...
Можно. Если вы работаете, если у вас крестофили написаны для d по dx, тогда можно. А у нас, ни разу они не может не коммутировать. У нас они какие-то взяты, и потом параллельным переносом перенесены. Вы не знаете, что это добивается до каких-то интегральных кривых, которые вам дают координаты.
Спасибо.
Да.
Голономного бальца мне этого достаточно.
Ну что там?
Ну, достаточно взять, просто не от нормированных, а голономных координат.
Нет. У нас все тут завязано именно на параллельном переносе. То есть мы и формы так распределяем, мы берем какой-то базис в точке P, и потом и двойственный к нему. И потом их распределяем параллельным переносом. Вот. И то, что у вас параллельный перенос вам именно задаст какие-то коммутирующие векторные поля, никто не обещал. Вот. Хорошо, супер, разобрались. Значит, вот этого нету, это антисимметрично, значит, вот этот слагаемый у нас убивается. Теперь вот это слагаемое. Значит, claim, maybe I need to go here. Claim number 3, I guess, I lost the count. Sum of gamma kji fj is 0. Sum over j. So let's see. So we have sum over j gamma I kj fj, and just this factor. I claim that this is just 0. Proof.
То есть, извините, вот до этого мы доказали в итоге, что pullback G, он там без вот этих промежуточных...
Еще пока не доказали.
Еще не доказали.
Мы вот, это самая такая нетривиальная техническая часть. Вот, и она сложная. То есть мы в процессе, давайте еще раз вспомним. Значит, мы где?
Мы доказали тоже.
Вот мы это доказываем. Мы это доказываем. Мы как это доказываем? Я хочу сказать, что производная от этого 0. И потом сказать, что вот это еще стремится к нулю. Стремится к нулю, когда t стремится к нулю. Ну просто потому, что когда радиус стремится к нулю, от угла мало чего зависит, грубо говоря. Вот. Ну, и так как это там был pullback, то есть dφ там 0. Вот. Поэтому вот логика такая. Ну, как посчитать производную от этого? Вот мы сначала ввели там омега, посчитали d омега. Там у Хилгасона называется как бы структурные соотношения. Вот. Посчитали d омега. Вот. И сравнили как бы pullback от омега и посчитаны, значит, двумя разными способами. Вот. Просто когда d действует на омега и t сначала по определению, либо когда pullback действует на d омега и t, который посчитан вот так. Сравнили, посчитали d омега и t с чертой по dt. Вот. Я говорю, что вот это 0, ну вот потому что f и t все в квадрате дают единичку. Это понятно, 0. Потом мы как бы с горем пополам посчитали, что вот это слагаемое 0. Теперь, значит, вот я говорю, что и это слагаемое 0. Просто вот по вот такой причине. Ну, хорошо. Значит, окей. So I am claiming that if I define V to be sum over Fi Vi. So let me just define V to be like this. I am claiming that nabla V of Vi is 0 for any I from 1 to n. It's from, but this guy, if you just expand it using this definition of V, and this will be just sum in terms of Christoffel symbols, which are written using this as a basis of sections. So this is exactly will be gamma kj I fj. So just again from the definition of Christoffel symbols. This guy equals to this. Now, why this is true? This is true because of definition of Vi. Actually, I'm claiming that V at a point Q is actually the derivative of gamma pq at 1. So 1 is a result, is a corollary to this, because Vi is family of. So Vi is a vector field, gives me a family of vectors which are parallel with respect to gamma pq, right? And so therefore, since it's parallel, just by definition, covariant derivative with respect to pq in the direction of pq gives me 0. So I just need to see that V is actually is like that. But gamma pq of t is just an exponential. I'm just going backwards through the definitions of exponential map, of VIs, and just, the matter of remembering all the definitions. Exponential of t sum over ai xi I. Right? Where these AIs are given by the derivative of this guy at 0. So this is just sum over AI xi I. Right? Therefore, gamma, and since gamma is actually yes. So now maybe I need to go to different board. So gamma is a geodesic. That's what I need to use here. So gamma pq prime at 0 is this guy. So therefore gamma pq prime at 1 is this guy. Right? And I need to act by tau 1. So it's geodesic. All tangent vectors along the geodesics obtained from its value at 0 by parallel translation. But then this is just some parallel translation is linear of AIX, and then tau 1 of xi I. And this guy is actually, by definition, is VI. So this is sum of AI VI. But AI is the value of f. So actually, this means that gamma pq prime f1 is f sum over fi of q, right, vi. And so therefore this follows, because v is defined like that. Okay, and we are done with claim 3, right? Very well. So finally we are done, actually. We've proved that there are no cross terms. No, not yet. We proved what? That the derivative of this is 0, right? So we proved that derivative with respect to t of this guy is 0. So it's constant with respect to t. Now I would like to take t and consider the limit of this as t goes to 0. So I claim that this is actually 0. Because just we need to see what is omega I bar, how it's defined. So I am claiming that omega I bar goes to 0. So because this goes to 0 as t goes to 0. Omega I bar is obtained from the pullback of phi star of omega I. So it's actually AI dt, right? We obtained it, plus omega I bar. So that's just definition of omega I. All right? And so, well, in the definition of the pullback, what I have to do, so this pullback at a point P, well, I need to consider omega at the point phi of P, and then add d phi of, well, if I am maximum some vector v of v. So what is important for me is that I need to compute d phi of v. Right? And I am claiming that this guy, well, I need some coordinate which is not t, which is like a angle coordinate, right? So if so v should be a vector field on a sphere, not in the radial direction, okay? And so what I'm saying is that d phi actually is you can imagine it as Coulomb vector, right? It's like d phi of d over dt and d phi of some angular, it's restriction on a sphere basically, right? So I'm saying that I don't know how to define this, how to denote this. I don't know, d over d theta. But I have a lot of angles, right? So this is one component. This is like a lot of components which go along the sphere, right? So I'm claiming that this guy goes to 0 as t goes to 0. And this is now clear. Why? Because, well, I'll just draw this picture. So t goes to 0, right? My phi is actually spherical coordinates, right? As t goes to 0, I'm rotating around the origin, actually, right? And there was nothing. So the derivative of phi is actually becomes 0 in the direction, in the angular direction, right? Because like I'm not going anywhere outside of 0. So basically, this is the reason, right? And so to get omega I need to substitute d over d theta here, and so therefore I have this result. Okay, makes sense? Doesn't make sense? Should I repeat something? For those who was...
Можно еще раз, какой план того, что мы сейчас все еще хотим поговорить, что вот этих вот смежных терминов...
Да, я говорю, что вот это вообще константа, раз такое выполняется.
Да.
А значит, что мне достаточно вот это посчитать там в какой-то точке. Я вообще хочу вот понять, что это 0. Ну и в какой-то точке или предел какой-то точки. Вообще говоря, она плохо определена в нуле, потому что там сферические координаты происходят с сферическими координатами. Вот. Присутствуют координатами, да. Ну я просто устремляю и говорю, что у меня как бы угловая часть, производная φ по угловой части, это просто 0, потому что вот вы когда близко к нулю находитесь, у вас ничего не меняется, когда ты просто вокруг вот этой точки, ну вы всегда находитесь в какой-то малой окрестности. Вот. Ну и понятно, что это можно формализовать, но давайте снова. Ну, неразумными средствами. Вот. Все. И поэтому я делаю, значит, вот раз это, значит, я делаю такой вывод, что поперечных, значит, I have no cross terms. Okay. All right. So this is a victory. And the result is that phi star of G is actually dt squared plus sum over omega I, sum over omega I bar squared. Right, since phi, yeah, okay. So this is the conclusion. Right? Is it clear why this, or should we go back to some formulas to see that? Because we had G is sum of omega I squared, right? So therefore phi star of G is sum over phi star of omega I squared. This guy is sum over I dt plus, well, so here I will have sum of I fi dt plus omega I bar squared. Then I'm saying that, okay, one of the claims say that cross terms here are 0, right? So therefore it's sum over fi squared dt squared plus sum over omega I bar squared. Now this guy, well, I can pull out dt squared, right? And this is just 1 because this gives me, so each fi gives me a coordinate of a vector on a sphere. And so coordinate is square to 1. And so therefore I have this result, which is very important, and we can now apply it to finish the proof of the theorem. But the idea I already told you. Right, so actually now I can compute the length of any curve, gamma. Right, so maybe something I should say. So basically I have, so let gamma, first of all, let gamma be a curve in NP. So in the theorem, it should not be necessary curve in NP, right? But first, let's discuss that if it's in NP, then its length is greater than length of geodesic. Greater or equal? Okay. Right, and so then what I want to say is that let me consider its in spherical coordinates, its components. And so it's just a notation. So in spherical coordinates, this will be some curve, well, curve on R, and a curve on a sphere, which I denote by V of S. All right. Then I can compute the length of this curve as follows. It's just integral from 0 to 1, and then phi star g of, well, this curve maybe I can denote by gamma 0 of S. Gamma 0 prime of S, gamma 0 prime of S, square root of this ds. So it's just by definition, and I changed the variables in integration. Okay. So then I'm using this formula, and this just says that this is just integral from 0 to 1. So now it looks like just the usual Euclidean product. That's the whole point of this. So if I have like a spherical coordinates, in these coordinates, G just reduces to computing a length in just Euclidean space. So it's just T prime S, where T of S is defined over the squared plus sum over omega I bar of V prime S squared. And then I need to take square root of this. and integrate over S. Okay, so suppose that I have Q, so take point Q is inside NP. Then it has some preimage under exponential map, so say Q is exponential of some V, where V is an M0. Right, then actually Q is gamma V of 1, just by definition of exponential map, right? And my gamma PQ is just gamma V. Gamma PQ is just gamma V in this case.
And this V is not the same as the third one, the...
Yeah, sorry. So this is V of S,
Yeah.
and that's V. Hopefully this will not... yeah, so I'll try to take this to make this V of S, yeah, just to make no confusion. Okay. Right, so let me continue. All right, so if I take this gamma PQ of S and take exponential of, like inverse of exponential of this for any S, well, this is just the inverse of exponential map of gamma V of S, right? This gamma V. And then this is what? So I can take, we know that I can multiply this by V by S and put here 1, right? Because you know that from the homework, for example. So this is exp SV of 1. So this, the result of this computation is that inverse of exponential map of any point along gamma PQ is just SV, where V is inverse of exponential map of Q. All right. So if I take, the result is that, okay, if I take gamma, which I started with and for which I computed length here, to be geodesic, so how do I compute the length? Just want to continue that for the case when gamma is geodesic. Then actually gamma 0, right? So this gamma 0, sorry, maybe not here, where was it? Why is it 9 out of 11? I have no idea. Wait, did I go backwards somehow? Okay. How did it happen? Okay, for those, for people who will sort this, this will be a nightmare. Now, how come did I go backwards? I have no idea. But okay, so this is my definition of gamma 0, right? And so I'm defining what is gamma 0. I would like to see what is gamma 0 when my gamma is gamma PQ, right? Phi is a composition of spherical coordinates on 0 and exponential. And I computed exponential inverse of gamma already, right? What I need to do is now to apply rho inverse. Rho inverse means that rho is this map. It just takes TV and maps it to TV, right? So, but this, well, again, V is very bad. So, so maybe like this. maybe W, right? But this W should be on a sphere, right? So if I have something like T of the form T W tilde for some W tilde, then actually the inverse of rho will look like the following. It will be W tilde divided by the length of W tilde in the second component. So this is like rho inverse. And in the first component, I will have T multiplied by the length of W tilde. So that's how rho inverse works. Right? Because W tilde was not on a unit sphere, so I need to normalize it. And then this guy should be multiplied by this normalization constant because, well, the product should give me this. Okay? So this is just how rho inverse works. With exponential inverse I computed, rho inverse works like this. So therefore, my gamma 0, exponential inverse is like that, and then rho inverse. So I'm saying that gamma 0 of S looks like this. S norm of V, and then V divided by norm of V. So this is how gamma 0 looks for the geodesic. And then I can now compute this. L of gamma PQ, L of gamma PQ is just then integral. You see what's going on? It just depends on S in this term. Right? This is just constant. So, so derivative of this component is just 0. So this does not. So V prime of S is 0. So this does not depend on S at all. Right? So geodesic and spherical coordinates looks just like that. It just goes along the radius. So therefore, there's no this term if gamma is gamma PQ. So there's this term which is I need to compute the derivative of this with respect to S, which is just V bar, V norm of V. So it's just norm of V, and then I need to take square of it and then take square root. So it's just norm of V, right? ds. So the length of gamma PQ is just a norm of V. Again, so what I'm doing is that I'm taking a point Q close to P, then compute inverse the pre-image with respect to exponential map of it. I'm saying that the length of geodesic that goes from P to Q is exactly the norm of this vector. That's the result of my computation.
Извините, а почему мы не можем вот просто сказать, что если мы... Короче, в случае геодезического у нас не будет вот этих вот членов, которые там,
Да.
сумма счет там, а если не геодезическое, то они будут, и тогда понятно, что...
Ну, как бы, не, ну можно это сказать и разойтись. Я просто хочу показать прям вот, что для геодезической... Ну, просто... Смотрите, я просто хочу сказать, что они будут, но вдруг вот этот меньше окажется. Вдруг вклад вот этого меньше окажется. То есть мне нужно сказать, что я все равно, вот вклад этого будет точно не меньше, чем геодезический. То есть до этой точки я должен все равно пройти все это расстояние по радиусу, ну, как бы, радиальное направление все равно должен все пройти.
Окей, хорошо.
То есть вот формально, почему бы вот этот, он как бы будет, конечно, но вдруг он будет меньше, чем когда геодезический.
Да, хорошо.
Вот. Поэтому мне нужно сначала для геодезической посчитать, а потом для абы какой и сравнить. Вот, для геодезической я посчитал. Теперь для абы какой. Значит, if gamma is not gamma PQ, then actually I'm saying that V prime of S is not 0. Right? Ну, как геодезическое выглядит? Мы знаем, Вот. Если здесь константа какая-то, но она всегда как бы понятно какая. Ну, то есть вот всегда тут должен быть вектор длины 1. Вот. То есть на самом деле, если тут константа, то тут понятно, какая она стоит. Вот. И направление тоже понятно. Поэтому если у меня какая-то другая кривая, то у меня, значит, v' от s для какой-то точки s, то, ну, то есть, что точка s, что это не 0? Okay, so I need to switch back to English. Right, so this just means that as a function of s, this is not identically 0, if it's not geodesic. Okay? Because if this is constant, then, well, it's just define this should be like that, and then it can coincides with geodesic. Okay. On the other hand, so this means that there exists I such that phi star of omega I of v prime of s is not 0. So this is locally basis of sections, right? Since this is not 0, then there exists some element which with non-zero element, which related to this gives me non-zero, right? Okay, but on the other hand, if I take dt, right, of v prime of s, so maybe I should go back to the other, not to squeeze writing in here. Нет, здесь тоже как-то 11 с 13. Ну ладно, тут какие-то... Ну, давайте 13. Okay. So now, yeah, so I'm saying that there exists I such that this is non-zero. Moreover, so phi star of omega I looks like this. It's just some I dt, right, or f I dt. Doesn't really matter what stays here at the moment, plus omega I bar. What I'm saying is that dt of v prime of s is 0, but the whole guy is not 0, so I'm making a conclusion that omega I bar of v prime of s is not 0. That's exactly what I need, because it means that this term will be non-zero for something which is not geodesic. So therefore L of gamma, according to this formula, is just greater than integral from 0 to 1, and then dt, so actually can write like this, t prime of s ds, right? Greater, strictly greater, because the term that I indicated there is greater than 0. All right? But this is greater or equal than t of 1 minus t of 0. Well, because, well, my function t of s, right, can go like this, right? So this is my t of 0, this is t of 1, right? It cannot, well, so I'm computing the length of really a curve in Rn, in R1 actually, right? Well, which is just, if it just goes from t0 to 1, well, it's just the distance between t0 and t1. But it can go like first to the right of t1 and then go back. So therefore, there's this inequality here. But t1 minus t0, well, t of 0 is just 0, of course, because it's just the origin, right? So this is just t of 1. So finally, I am saying that this is, okay, so finally I need to write this. So my gamma of 1 is a point Q, right? Because, well, it's some other curve between P and Q. So my geodesic gamma PQ and some other curve which is gamma. So gamma of 1 is Q. That I know. And also I know that phi inverse of gamma of 1, which is the same as phi inverse of gamma PQ of 1, is just, well, I need to look here. So it is just V and then V over norm of V, right? Because gamma of 1 is just the same as gamma PQ of 1. It's just my point Q. Gamma PQ of 1, it's a phi inverse of it. I know how it looks like, so I shall put S equals 1 in here. It means that T of 1 is just, it means just that T of 1 is V, is the norm of V, and I am done, right? Because I know that geodesic, length of geodesic is the norm of V, and length of any other curve is greater than the norm of V. And I'm done. But I'm done with the curve which goes outside, which is inside NP. So what I proved is that, okay, I have curve gamma PQ, the curve inside. It cannot go outside of NP. But the statement is about any curve. It can go outside and then turn back. So how to deal with this situation? This is now easy. So now let me go. So if my gamma just a couple of lines is curve in X which goes from P to Q, right? And Q is inside NP, P is inside NP, but image of gamma is not inside N of P. What to do in this case? Well, we then can take delta prime, which is between V and delta. So delta is a radius of our sphere around 0, right, in the tangent space, right? So let me take something in between inside NP but greater than the norm of V. I'm saying that there exists some S in the following interval from 0 to 1, such that the norm of an exponential inverse of gamma of S is delta prime. So what I'm saying is that, okay, so this is the picture. So I have P, I have Q, right? And I'm saying that, okay, let me take radius, which is in between Q and the maximal radius. Okay? And I'm saying, since I have a curve which goes outside first, there is some point which is in between these two spheres. So it goes outside, so at some point it crosses the first sphere, and so therefore this curve at some point, the inverse of exponential will have such a norm. Okay, but then if I define this point, just know this point to be Q tilde, right? Then I know that L of gamma of P Q tilde, that's just by what we proved, is less than L of gamma, right? Well, it's less than the length of segment of gamma, right? So therefore it's less than the length of the whole gamma. But this is just delta prime, right? And then delta prime is actually greater than the norm of V, just because we chose it like that, right? And the norm of V is actually the length of gamma PQ. And we're done, right? So L of gamma is greater than the length of gamma PQ. Right? Да, правильно. Так. И вот так. Okay, and so we proved it here. No, I think this is like, this is something, so to look at this proof is variable, right? So the idea is that you have no cross terms. By the way, it means that if you, so for example, you can right away compute like a geodesics on a sphere. Because if you found like some coordinates such that you don't have cross terms, it just follows from this proof. If you found some coordinates without cross terms, right, like a spherical coordinates, then if you go around like the long radius, it will give you geodesic, right? Because everything else will be of greater length. It just follows from this proof. Okay. Anyways, I'm done. I wanted to finish this, so we don't go back to technical steps. But I don't know how much time do we have left.
Нисколько.
Ну, как бы, да, люди уже устали. Ну хорошо, все, давайте тогда.
Почему мы опять справились? Нам было ровно набрало некоторое число и набрало другое число.
Да.
Чтобы обратно нужно было, как бы, если было ТВ,